Yeah, Assalamualaikum and a very good evening to all my friends. Uh, and myself is and my lecturer is Rizal. And today we are from Group E want to present about this break for meaning process. Okay, before we start, I want to introduce you about my group members. Firstly, Muhammad Kamil Naim. Second, Muhammad Iqmal. And third is me, Muhammad Ali Fauzan Biawasan. And lastly, Fakir, Muhammad Fakir bin Zufarus. Okay, objective. The objective of this project is design, robotic, and manufacturing process have led to significant increase the automation of automotive production. Other than that, the objective of this project is also demonstrate ISO programming for turning in using rapid traverse G00 for positioning. In addition, to understand the able to explain the concept of the rapid traverse G00 and linear interpolation G01 movement system with it in more details. Managed production is by using CNC machine to produce a component. Next, introduction. What is introduction Simulator 840D? The basic for almost every definition of machinery is Simulator 840D, complemented by outstanding drive and engine technology, efficient hardware architecture, and intelligent control algorithm guarantee machine with the highest dynamic efficiency and accuracy. The Cinematic 840D CNC is complemented by a comprehensive array of IT integration solutions. Siemens Machine Tool System secure the highest machine availability and optimum productivity based on this creative leading edge solution. Next, what is milling machine? Milling is the process of cutting and drill material like wood or metal. A milling machine, regardless of whether it operates manually or through CNC, uses rotation cylindrical to call a milling cutter. It is held in a spindle and can vary in form and size. The main difference between a milling machine and any other drilling machine is the ability to cut in different angles and move along different axes. For this reason, there are several kinds of milling machines, which are designed by number of movement axes. Okay, what is milling machine? Okay, firstly, two-axis milling machine can cut hole and slot in the X and Z axis. In other words, this machine will only cut vertical and horizontally, but only in one direction. And for three-axis milling machine and the Y axis. This is the most common variety of milling machine. You can cut vertically and in any direction, but an object like spear will need to be done one half at a time. This is because it will be three axis and it is not possible to cut from below. For four axis, milling machines are not complex, but they have the ability to rotate the X axis like lathe. And next, 5-axis milling machine incorporate rotation in both the X and Y axis. This is the most complete milling machine you can have. This allows you to shape bones, aerospace structures, car models, medical products, and pretty much anything else you can imagine. Lastly, CNC milling machine can have any numbers of axes in bracket 2 to 5, but are operate through a computer, no manual operation required. Next, I give this presentation to Fakir. Fakir, can you explain about use of CNC milling machine and operation?
Okay. First, use of CNC milling machine and operation. Digital technologies and CNC milling machine allow for the resolution of many problems which cannot be easily solved using prior method. The technology improves the working process the way they work more effective and more efficient. For example, without a CNC milling machine, the process of cutting metal for car part or even aerospace component would be much easier. With the support of computer program, one can access and create high definition design that are easily converted into Cartesian coordinate. This process even help lower the cost of prototyping. Use of CNC and operation. But these technological machines aren't only for industrial use. Here are a few other areas to which CNC milling can be applied. First, cabinet. Second, furniture. Third, woodworking. Fourth, aluminium. Five, prototyping and modeling. There are also a wide range of hard and soft solid material that a CNC milling machine can cut. Aluminum, steel, titanium, copper, bronze, zinc, PVC, nylon, and wood. Yeah. This is our group part chosen for milling. Break. What is this break? The part we choose for this project is called breakdisk. The breakdisk or rotor is the rotating part of a wheel disc brake assembly against which the brake pads are applied. The material is typically grey iron, a form of cast iron. The design of the disc varies somewhat. Some are simply solid, but other are hollow out with pin or vein joints. Together, the disc to contact surface usually include as part of a casting process. The weight and power of the vehicle determine the need for ventilated disc. The ventilated disc design help to dissipate the generate heat and is commonly used on the more heavily loaded front disc. Our group chose this part because it has required to make pre-milling operation. The three operations which are roughing operation, finishing operation and drilling operation will be produced by using merit train software. Type of this break for our product. This dimension for this break group by Katia software. This is our example simulation for train. You can play. Okay, next. That's all from me and continue Naim for that. I give to Naim for
And can you explain about this?
CNC milling operation. CNC milling is a machining process suitable for producing high accuracy, high tolerance part in prototype, one of and small to medium production runs, while parts are typically produced with tolerance ranging between 0.001 into 0.005 in. Some milling machines can achieve tolerance of up at 2 and greater than 0.0005 in. The versatility of the milling process allow it to be used in a wide range of industry and for a variety of part feature and design, include slots, chamfer threads, and pocket. The most common CNC milling operation include First, face milling. Second, aglo milling. Third, plane milling. And form milling. Next. Face milling. Face milling refers to milling operation in which the cutting tools axis of rotation is perpendicular to the surface of the workpiece. The process employs face milling cutter which have teeth part of the properly and tool face, with the properly teeth primarily being used for cutting and the face teeth being used for finishing application. Generally, face milling is used to create flat surface and contour on the finished piece and is capable of producing higher quality finishes than other milling processes. Both vertical and horizontal milling machines support this process. Type of face milling include end milling and side milling, which use end milling cutter and side milling cutter respectively. Next. Plane milling. Plane milling, also known as surface or slab milling, refer to milling operation in which the cutting tool axis of rotation is parallel to the surface of the workpiece. The process employs plane milling, which have teeth of the properly that perform the cutting operation depending on the specification of the milling application, such as the depth of the cut and the size of the workpiece. Both narrow and wide cutters are used. Narrow cutters allow for deeper cuts, while wider cutters are used for cutting large surface areas. If a plane milling application requires the removal of large amount of material from the workpiece, the operator first employs design path approximate geometry. Then, the operator introduces a finite tooth cutter, fast cutting speeds, and slow feed rates to produce the details of the finished part. Next, next, angular milling. Angular milling, also known as angle milling, refers to milling operation in which the cutting tool axis of rotation is at angle relative to the surface of the workpiece. The process employs single angle milling cutters angle based on the particular design being machined to produce angle features such as chamfer, serration, and grooves. One common application of angular milling is the production if of the dovetails, which employs 45 degree, 50 degree, 55 degree, or 60 degree dovetail cutter based on the design of the dovetail. Next, form milling. Form milling refers to milling operation involving irregular surface contour and outlines such a path with curve and flat surface or completely curved surface. The process employs form milling cutters or fly cutters specialists for the particular application, such as convex, concave, and corner routing cutter. Some of the common applications of form milling include producing hemispherical and semi-circular cavities, bits, and counter, as well intricate design and complex part with single machine setup. Next, Ikmal.
This is a project task distribution. First, Muhammad Kamirul Naim, documenting project report, producing CNC code simulation in numeric Sinotrain. Second, which is myself, Muhammad Iqmal bin Masani, producing CNC code simulation in numeric Sinotrain, finalizing project documentation. Third, Muhammad Daniel Fauzan bin Abu Hassan, producing and designing idea for project. And last, Muhammad Fakih bin Zulfairuz, adjusting the dimension to fit. Okay, for a process to manage, we use shop mill and program guide cement. First, process for shop mill insert program header, which is set up the material with use cylinder shape and diameter 245 mm and the thickness is 32 mm. Second, set up safety distance with material position 1 mm. Next, set up program header including G code, M code, T code, and S code. This is how we set up a contour for cylinder shape. After set up contour for cylinder shape, next process is roughing and finishing. Lastly, make a chamfer process for the first level. For the first step, next. Okay, for the first step, offset the machining parameter in program header as shown in figure below. Milling using face mill 63. Okay, we use cutter 60 cut 143 and diameter. For the chamfer process, next make a chamfer using drill 10 mm with depth of chamfer 2 mm. Then make a pocket measuring 126 and in diameter using a cutter 60 and make finishing for pocket. This is drilling process. The first drill process is to drill the hole using drill tool diameter 15 mm with through drill hole. Then make a hole or deep hole drilling. Cutting depth 38 mm using drill 15. Next. Okay, this is example for drilling process. Drill for hole using diameter 15 mm with through drill hole. Next. Next, Fauzan. Okay, this is a simulation process after we use sinomeric sinotrain. Okay, the final result after running simulation, the length of can you previous okay, the length of simulation time is 23 minutes. If run this product on machine in 24 hours, you can produce this product until 60 pieces. Next. This is a program guide G code for make this brake process. Next. Okay, for conclusion, This project is a success using CNC programming support systems such as manual guide, FANUC, or shop mill cement to generate NC code for simulation. Also, offline using a CAD CAM systems such as CATIA, also a success for measurement on CATIA and drawing. These often involve more complex shape to be machined or a series of operations. Okay, that's all from my team. Thank you very much.
Thank you all. Thank you all.
Thank
Thank you very much.
you. Thank you very much.